This is OXDF, and today I'm looking at baby SQL analysis from the RunCode competition in around November 11th. And this is another one of the intermediate challenges, so let's go ahead and dive in. Our snarky interns decided to push some netflow data into an SQLite DB to make their analysis easier for them. They've graciously given us access, and now that I have this database, I need to do some analysis, identify the number of bytes sent from the source address to destination address, print the most bytes sent to the least bytes in the format below. Example database found here, so go ahead and download that. And the input, so basically I'm going to run my program here. I'm going to pass it the database as an argument, and then I'm going to get out, it looks like source, arrow, dest, colon, and then bytes. And it's sorted by bytes. All right. Looks like we can give that a shot. So let's come here and move, what was that called? What did they call it? There we go. That got the database over here. So just like in the previous video, I'm going to go ahead and start by looking at the data. So I'm going to start with SQLite and see what I've got in this database. So identify our tables. There's one table, netflow. Good. Describe netflow. Is that not the right? Oh, it's not describe. It's schema. Schema netflow. Okay, so each column here is going to have an int, primary key, source address, source port, destination address, destination port, protocol, bytes in, bytes out. Okay, so and what I'm looking for is, let's see if I can do this right, the bytes sent from a source address to the destination address. So in this case, I'm going to care about the source address, the destination address, and probably the out bytes, I'm guessing. Since there's a little bit of ambiguity there because it's not clear whether they're, I guess it says they want the bytes sent from the source, so that'd be the out bytes. But we'll play with it and figure that out. In fact, we can do that where we can say, let's look at one of these examples. Let's pick one of these at the bottom where it's small. So we can do select star from netflow where source address equals, yeah, I think that's going to work. Let's test it. Oh, okay, and there's a lot. And dest address equals, where's my, let's grab this one, 116. Copy, paste. Okay, there's only one row there. That's nice. See, how do I put on, I think it's headers on. Sweet, let's try again. Okay, so IP, source address, source port, destination address, destination port, protocol, layer 7 protocol, bytes in 76, bytes out 76. Well, that's not helpful. I was hoping this would be different and I could see which one was 76. Let's try another. Let's just try replacing. So this is the same, but I would go to .4 over here, and I'll give a new destination address. Although this has got the same 76, so I wonder if I'm gonna get the same results. Yeah, 76, 76. Let's pick one that's a little bit different. How about here? The .3 to this one right there. Control W gets rid of a word on the command line, and then there. Okay, so we're looking at, let's see, that is the port, the protocol is 6, the next protocol is 1. That doesn't make a lot of sense, but okay. In bytes, out bytes. It should be in packets, out packets, TCP flags. Yeah, okay, so they're definitely different here. And let's see, one is like 38,000 times 1, 2, 3, 4, 5, 6, 7, 8. So like 40 times that's 3. If I just assume these are all roughly 40,000, multiply 40,000 by 8, gives me 8 times 4 is 32, so 320,000. And if it's this one, what are we looking at? 300,000. Yeah, okay, so I've in case that wasn't clear, I was kind of mumbling through there, I basically said one of either this column or this column is for the bytes I'm looking for. And so just quickly, there's 8 rows. I guess this is roughly 320,000. There's 8, if these are 5,000 each times 8, there's roughly 40,000 total. And so I come back over here and it's, 308,000, which it's a little less than 40. That makes perfect sense. That's the fit. So I could probably do some SQL magic to sum that up, but I feel pretty good now that that's what I'm looking for. So what I can do then basically is I can start to say what I'm really looking for here is let's see, that's out. Yeah, in bytes. Yep, in bytes. Okay, so now I know what I'm looking for. So I've got a pretty good idea there, at least enough to give it a try of what I want to build. I want to read the database. I want to collect things based on the source and destination, and then I want to sum up the in bytes into a value. So let's go ahead and start our Python here. Maybe SQL.py. Put in our shebang. I'm going to import sys because I need to be able to read that. And then I also need a library to read SQLite. So Python SQLite. I bet you that's it right there. SQLite 3. The tutorial seems fine. What a poor tutorial. Let's see. Tutorials point. I have some code. I'm just looking for some code I can run here. Okay, there we go. So I'm going to import SQLite 3. I'm going to connect to the database. I don't want to create a table. I don't want to insert. Select. So basically, I'm just going to connect to the database, and I'm going to use that object to run queries. And then the result is going to be, I can just loop over the rows. Okay, that looks easy enough. In fact, we'll just grab this. That paste that in, use that in a minute. Okay, so import SQLite 3. All right, so connection. I'm going to connect to not test.db, but I'm going to connect to sys.argv1. Let's do it with a. I don't need to print that I open the database, and then I'm going to select. Let's see, we'll just do a select star. Well, no, it's not. What do we need? We need source, dest, and bytes, in bytes. So we will do vim. Come back here and we'll do source address, dest address, and not and in bytes from. This was netflow. And that should get us that. So now I'm going to do. I can loop over the row and. Let's get rid of this because we don't need any of that. We don't need to print. So what we're going to do here is we're going to create, we need a way to store and sum up our different byte values because we've already shown above in the data that there's going to be more than one row for each pair. So what I can do is this is where I would like to use a dictionary. So I will do res equals that. And so then for each one, what I'm going to do is I'm going to say, I want to create the tag that is the format. What am I looking for here? So the output looks like this. So I'm just going to create a string that looks like flow string is equal to, and we'll put that in there. Now this is going to be row. So we're doing F string, so we can do row 0. And then this is going to be row 1. Because it looks like it takes them in, this is 0, 1, 2. So this is row 1. And that looks fine. In fact, this is one of those times where I say, let's test it. Python baby SQL, and then we give it that database, and I will put the -i on here. And this will drop me to a Python terminal at the end. So now it's run all this code. So by that logic, the flow string, whatever the last row in the database was, I should still have in flow string. And that looks good. I mean, I guess I could go verify that, but that seems fine. So so now that I have the string, what I can do is I can say res sub flow string, because that will uniquely define the thing. And and I'm going to do plus equals row sub 2. Now this is going to fail, and the reason it's going to fail is it's going to want to do plus equals. It's going to say, oh, well, you're trying to add this value to the current value of flow string, and that doesn't exist. And so what I'm actually going to come up here and do is use another pretty cool construct I like a lot from the collections library called the default dict. And what I'm going to do down here is, instead of making that a dictionary, I'm going to make it a default dict. AUL dict, and it's going to be a default dict where the values expected are ints. And what that's going to do is basically say, I could give it another value, but by default it chooses 0. So now when it gets to here and it says, oh, I go to grab the first one and it doesn't exist, it's, instead of throwing an error, it's going to say, oh, okay, well, then I'm just going to give you 0. And therefore everything will exist. So hopefully that makes sense. Now I can come up here and rerun. And I can look, let's see, playing a res, 38 lines, res sub 1. Oops, let's try typing correct. Oh, I killed it. Res sub 1, 0. Oh, because of course, res sub 1 is not a thing. Where was my flow label from before? Let's try to see what that looks like. And really, again, right here, I'm just sort of testing to see if this looks reasonable. I could even come, do I still have that value? It doesn't have the correct answer though. Oh no, let's try actually finding that. It does have the correct answer. 50, 39, 139, 50, 39, 139. Sweet. So I've now can feel pretty confident. I've got 38 output values. That is more than, oh, that's exactly what they have. They've got 39 lines, but the first line is the code. So that, I feel pretty good that I probably have a good database here of going from a source and destination pair to a bytes number of bytes sent. And so now I just need to do the, I need to just do the print itself. And so I need to sort my results. And so what I can do is I can call the sorted function on res. This does not actually sort res in place, but it returns a copy of res that is sorted. And if I just sort like this, it's going to sort based on, I believe, alphabetically on the keys here, which is not what I want. I want it sorted on the values. I'm going to go ahead and give it a key, and the key is going to equal, and what key actually takes a function that returns either it returns values that then can be compared against each other. So what values I want compared are the actual numbers there. So if I take something, so I'm going to create actually just a Lambda function here in place, and I can well, let's see. What I could do first is I'll come up here, make this big so you can see. And define def sort func x. So every object is going to be passed in here, and what I really want to know is if I take I just want to return res sub x. So when you are sorting over a dictionary, what gets sorted is the keys. And so like the keys, so for each, it's going to try to compare the keys. And so if I'm going to pass a different, if I'm going to create a different sort function, each key is going to get passed in that sort function, when really what I want is the value at that place. So I'm going to call res on that key to get the value and return that, and then it'll sort based on all of those. So I can do it like this. It's actually cleaner. Well, I'll leave it here. I won't delete it yet. Come down here and so I can say sort func like this, and it will return the sorted res that way. But because that takes up so much space to just do that simple like return thing, I can do what's called a lambda function, which says lambda of x and then say res x, and that is effectively the exact same thing as what I just did up here. But it's just a heck of a lot. Well, it's only good for really short functions, but if you've got a really short function, it's much cleaner. So there's my sorted. Okay, so I'm done sorting. Well, presumably. So we'll do for line in sorted. line's probably the wrong word, but it'll work for now. Print, and then this will be an F string where we're going to sort line, colon, space, res subline. It's going to bug me that I called it line, because those aren't really lines. I'm going to call that key. Key. Let's see. I suspect something's going to not be right here, but let's give it a try. Okay. Oh, it helps if I can spell Lambda. Oops, it helps if I can spell Lambda. There we go. Let's try that again. Try completing my sentence there. And that looks pretty good. The only issue I have here is it looks very good in reverse order. So that's easy enough to fix. We'll come back here. And why don't we just return negative res. That looks pretty good. Let's pull up the expected results. Just scanning through, this looks pretty good. What about these ties at the bottom? Do they look the same? Looks like they do. These are looking good. Okay, I can do my expected hash thing. So you can check out the, I did an overview of RunCode video earlier. But basically you can use this hash function to see if, to compare your results against theirs exactly. So my RunCode hash 416C, and that looks, so basically I just proved that my output for the example input exactly matches the expected output. For more details about, this is just an alias I created that does this SHA-1 hash for you. But anyway, the point of this is right now, my at least for this example, my output exactly matches their expected output. So that looks pretty good. We'll go ahead, and seems like a good place for a first submit. So any second now, it should pop up right here and show me, and there it is with success. So we're all good. That wraps up this challenge, and I'll talk to you for the next one. Thanks.